Electricity has always been a part of the human experience. Often, it was not understood. In ancient times, electricity could be observed. Lightning would come from the sky, strike a tree, destroy it, or somebody would pick up an electric eel thinking this is going to be delicious and receive an immense shock. This electricity, as we know it, to them was a mysterious force, stronger than most forces in nature, yet at the same time incredibly mysterious. Nobody knew where it came from. Nobody knew when it was going to arrive. This caused electricity to move into the realm of mythology. Many ancient cultures worshipped many different gods, and many of these gods had electricity that was tied to them. Many figures have been found with gods holding lightning bolts, predecessors to more commonly known gods such as Thor and Zeus. It was something that was out there, but that was unattainable for the human mind to be able to figure out. Around 600 BC, a Greek named Thales of Miletus made an important discovery. He found that if he took a semi-precious gemstone called amber and rubbed it with a piece of wool or fur, he could create a charge off of that. Now, it wasn't a big charge, it was just enough to lift the hairs on the back of his hand or to pick up light objects like feathers. But what he didn't know is that he had just discovered static electricity. He knew he was onto something, he just wasn't sure what. So he documented it, and in further centuries, other scientists eventually figured out what he had discovered. They then referred back to his original writings, and they named this mysterious force that could pick up light objects after what he had discovered it from. The Greek word for amber is actually electra, which is where we get the root for our words electricity, electronics, and electrons. Thales of Miletus was one of the earliest forefathers of electrical work. During the 16 and 1700s, science was regarded as a form of entertainment mostly. Sure, there were interesting discoveries that were being made, but for the most part, people really didn't understand what was going on. However, there were some serious scientists out there who did make important discoveries and who documented them and tried really hard to understand them. And we owe our knowledge of electricity to a few of them. Back in 1600, William Gilbert, who was a physician for the Queen of England, discovered magnetism. He discovered charge, and he started to name electrical properties. In the 1700s, around 1729, Boyle discovered that electricity could be conducted along wires. In the 1730s, Benjamin Franklin was notorious for his death-defying experiment of flying a kite in a thunderstorm. And by 1745, a Dutchman named Peter von Munchenbroek created the Leyden jar, which is the earliest form of capacitor and was a way for people to be able to store electrical charge. Now, these oddities were used as entertainment. People would shock themselves off of the Leyden jar that von Munchenbroek had created, but the scientists themselves were still taking these forms of entertainment back into the lab and experimenting with them. They discovered that you could complete a circuit from a Leyden jar, and that circuit would then dissipate power. By early 1800, the very first battery was created by Alessandro Volta. And Alessandro Volta gives his name to the volt, our electrical unit of charge. The 1800s were a heady time for electrical development. Following Alessandro Volta's development of the battery, all of a sudden there was a portable power source that other scientists could use to power their own experiments. As a result, many scientists worldwide began experimenting with electricity. In France, André-Marie Ampère and François Arago confirmed the relationship between electricity and magnetism. Ampère's last name is our unit for current, the amp. In 1821, Michael Faraday in England developed the principle of electromagnetic rotation, which would later be the key to developing the electric motor. And in 1826, George Ohm from Germany defined the relationship between power, voltage, current, and resistance. He named that Ohm's law. By the 1830s, using his invention of an induction ring, Michael Faraday proved that electricity can be induced by changes in electromagnetic fields. Faraday's experiments about how electricity current works led to the understanding of electrical transformers and motors. However, he was a great theoretical scientist. Somebody else had to still put it into practice. That person was Thomas Davenport, who in 1837 invented the first electric motor, an invention that is used in most electrical appliances today. In 1841, James Prescott Joule showed that energy stays within an electrical circuit. A unit of thermal energy, the joule, was named after his discovery. By 1844, Samuel Morse figured out that electricity could be used to send messages a long distance. He invented the electric telegraph, a machine that could send messages long distances across the American plains. In 1878, Joseph Swan invented the very first incandescent light bulb. However, his light bulb burned out relatively quickly. Thomas Edison bought the patent for that and developed further work on the incandescent light bulb. By 1879, he had invented an incandescent light bulb that could be used for about 40 hours without burning out. This was the start of our electrical revolution. By 1882, using everybody's desire for light, Thomas Edison opened the Pearl Street Station, one of the world's first central electric power plants. It was a DC power system, unlike the power systems that we use today, which use AC. Nikola Tesla was still working on AC. By 1883, he had invented the Tesla coil, a transformer that changed electricity from low voltage to high voltage, making it easier to transport over long distances with very few losses. By 1884, he invented the electric alternator, which would then create that AC current that he was researching. Using AC developed by Tesla, William Stanley Jr. developed the induction coil transformer and an alternating current system. Then in 1888, Nikola Tesla demonstrated the first AC electrical system. This was huge. His AC system included everything needed for electricity production and use: generator, transformer, transmission system, motors, and lights. George Westinghouse, a financier and the head of the Westinghouse Electric Company, was so impressed that he bought the patent rights to the entire system. And by 1893, Westinghouse Electric Company had used an AC current system to light Chicago's World Fair. This was the first large-scale usage of electrical to go provide lighting and power to any sort of machines. In 1904, John Ambrose Fleming invented the vacuum tube. The vacuum tube was key to all of our further developments about electronics. During World War II, in 1943 through 1946, the first general-purpose electronic digital computer, called ENIAC, Electronic Numeral Integrator and Computer, was built. It consumed a phenomenal amount of power and could do far, far less than the average pocket calculator. However, it was our very first computer. In 1950, John Hopps from Canada discovered that if a heart stopped beating due to cooling, it could be started again by artificial stimulation using mechanical or electric means. This led to his invention of the world's first cardiac pacemaker. By the 1950s, IBM had created the 701 EDPM, which was our first commercially successful general-purpose computer. From the 1950s through to today, there have been many developments, but most developments are happening on a microscopic level in electrons, in electronics, in computer chips, in speeding up all of our systems. We're no longer seeing the huge development of AC theory because most of the theory about AC systems has been observed under microscope or in lab at this point and has been written down. This electricity that we use every day around us powers our world, and someday, as an electrician, I hope you will help to use it to power other people's worlds as well.